So in this video, we will see about randomized quick sort. So before going into this video, assume that everyone knows about quick sort algorithm. So the limitation of the quick sort algorithm. The quick sort algorithm it follows divide and conquer approach. So the time complexity can be derived by using a recurrence relation. So in the best case is when the pivot element exactly split the entire array into two equal sized halves. That means it exactly split in such a way that both left subarray as well as right subarray have equal size. So this is best case in quicksort. So for that best case, the recurrence relation is T of n equal to 2 into T of n by 2 plus n. So that n is nothing but the time taken for the partitioning process. So if you solve this recurrence relation by using substitution method or Master's theorem, anything, so it will give O of n log n. So this is the best case. But what happens if the input is already shorted? So there is the worst case scenario of the quicksort. For example, if the input is taken this is input 2, 4, 6, 8, 10. So this input is already sorted. So in the as usual in the quicksort, we need to take first element or a last element as a pivot element. So in this example, I am taking first element 2 as a pivot element. So after partitioning, so partitioning nothing, we need to find the exact position of that pivot element. That means all the elements left to that pivot elements are smaller than the pivot element, and all the elements right to the pivot elements are the greater elements. So since this is sorted array, the first element is the smallest elements. So the exact position for the first element itself is first. So it split that array in a such a way that the left subarray contains only one element, that pivot element, and right subarray contains four elements. That means n minus 1 elements. So now the recurrence relation for this input. So the left subarray contains only one element and the right subarray contains n minus 1 elements. So T of n equal to 1 plus T of n minus 1 plus n. So this one is size of the left subarray and n minus 1 is the size of the right subarray. So here why we give 2 into n by 2 means both left subarray and right subarray contains n by 2 size. So T of n by 2 plus T of n by 2, that is 2 into T of n by 2. But here in the worst case scenario, if this already sorted, then it becomes T of n equal to 1 plus T of n minus 1 plus n. So if you solve this recurrence relation by using Master's theorem or substitution method, it gives time complexity O of n squared. So in the randomized quick sort video already told that randomized algorithms are used to escape from the worst case scenario or worst case time complexity of the existing approaches. So in that video I already told you the example for the randomized algorithm is randomized quick sort. So this quick sort worst case time complexity of n squared. So we can use this randomized approach to reduce this worst case time complexity or to escape from the worst case time complexity. So how quicksort randomized quicksort works means it is very similar. Moreover, it is similar to the quicksort approach, partitioning, selecting a pivot and find the exact position of the pivot and partition the array using the pivot element. So here before selecting the pivot, each time random number between the 1 to n. So between 1 to n means the size of the array n. So a random number is generated, and the selected random number is used as a index, and the random element at that index will be swapped with the first element of the input, and then after the swapping we need to do the partition. Suppose for the same example, so we have the same example 2 4 6 8 10, size of the array is 5, so initially it will generate a random element between 1 to 5. Suppose it generate the random element is 3. So now the third element in the input is 6. So the 6 is swapped with the 2. 6 and 2 are swapped. So now the input changes. So 6 4 2 8 10. So now as usual quicksort algorithm, the first element 6 is used as a pivot, and in the partitioning process the correct position of the 6 is found. That means all the elements which are less than 6 are in the left side, and all the elements which are greater than 6 are in the right side. So now we need to partition that array, split that array. So left subarray is the elements that contains there are less than that pivot element, and right subarray contains element that are greater than. So left subarray contains 2 and 4 which are less than, and right subarray contains 8 and 10 which are right subarray. So now, so for the worst case scenario, that means the given input is already sorted. For the worst case scenario itself, the entire input is splitted into two equal sized sub arrays. So the recurrence relation now for the worst case also the recurrence relation will become T of n equal to 2 into T of n by 2 plus n. So this randomized quicksort is used to escape from the worst case scenario of the quicksort. So if you solve this by using any approach, it will give of n log n. So after that, if suppose for the left subarray, we need to do the same process. It contains two elements, and then a random input is generated. Suppose the random input is 2, then that 4 will be swapped with 2. Again, it will be unsorted, become unsorted array. Then we need to do the same process. So actually, the random element, instead of using that generating random element from 1 to n, we can generate random element from 2 to n. Suppose you are using the first element as the pivot element. Okay. So now, whether in all cases we can able to this randomized quicksort generate the best case time complexity of quicksort, can we able to guarantee it? No. So in randomized quicksort also, in some cases it may generate the worst case time complexity. Suppose after swapping, if the array is sorted, become sorted. Suppose if the original input is like this 4 2 sorry uh, 6 4 2 8 10. Suppose if you use randomized quicksort and it's a quicksort select third element as a pivot element, then if you swap that third element of the first element, now it becomes the quicksort that are unsorted input becomes sorted input. But it is very rare. The chances for such rare scenario happening, this rare scenario is 1 by n factorial, which is very less. So this randomized quicksort actually is used to overcome the limitation of the quicksort. The limitation of quicksort is in most case scenario, if the input is already sorted, then it gives O of n square time complexity. So we introduce the randomization to escape from the worst case scenario. Thank you.